Hello students, in this session you are going to learn about manual clustering. So we have done document based, vector based, all those things. So we'll see about manual clustering. So what is meant by manual clustering? So here we have to check how many set of words you are going to use. Like this manual thesaurus construction depends on set of the words. If I am taking one cluster, so what are the words I use here? So this have to be decided. And remember, unrelated words. We should not include the unrelated words. For example, we can also use all the tools like KWOC, KWAC, KWIC for determining the useful words. So what is meant by KWOC? So keyword out of context. Okay. So when we are writing all these elements as a cluster, see we are talking about the cluster. So in this particular cluster, we'll find one keyword. Okay, for example, connect is our keyword. Whenever I am asking connect, the search will go to this particular cluster. The name may be connected, connects, or connecting, whatever it may be. So the keyword will be a connect. I cannot add detach. For example, detach in this cluster. So that is the basic meaning, that unrelated words. Okay. So we can use so many tools in order to use that. Next one is keyword and context. Keyword and context, KWAC. So we have to check the context here. Previously in KWOC, we have checked the context, connectivity. Here you have to check the keyword and context value. It is out of context, it is within the context. So this is one example. 1 second, yeah. So if you take here, we have a term called chips. So like this we have to tabularize. So the frequency is 2, means how many times the word have repeated? 2 times. Where it has been stored, document 2 and document 4. So this can be formed one cluster. Next one is computer. You have 3, document 1, document 4 and document 10. Design, only once it is there, document 4. Memory, thrice, and it is in the clusters called document 3, 4, 8, 12. Now next one is AC. Okay. So KWIC, what we are doing? Chips. What is the meaning of the chip? Computer design contains memory. So design, what is a computer? So design contains memory chips. Design contains memory chips and computer. Memory contains this one. So whenever you are alternating or you are changing the words, so the complete context will be stored according to this. Okay. So next one is what is meant by chip? Computer design contains chips, computer is there, design is there, memory it is there. So here also memory it is there. Okay. So but here keyword is not there, but chip implies memory, right? Design is not there, but it will design this one. So computer is not there, but who will store this? Chip is not there, who will design this? So like this you will check here, you will check whether the word is there or not. Okay. So here I have the chip is there, here computer is there and design is there. Like that you have to use this technology in order to store the values. So if you see the diagram in the previous thing, here you are using KWIC and KWAC, we are going for homograms, and once these terms are selected and they are clustered, and you have to identify what are the relationship in between, and you have to interpret the strength of the relationship. Okay. So this is also part of the art of the manual creation. So if I taking chips and what is a computer, if you take the relation these two, I can rate it as 0.2. If I take memory and chip, so here it is having 10. Okay, because whatever it may be. I can take 100%, 0.2%, whatever it may be, or 20%, right? Because chip and computer, okay, chips are available in the computer, but the relation is not that much, bond is not that much. But memory and chip, because chip will only have the memory capacity, right? So like that you have to find out the relationship for all the words in order to form the cluster. So there are different other techniques for generating this particular term clusters, okay? So using statistical one. So when the number of clusters are created is very large and you don't know what is the starting point and you want to generate more cluster, you have to go with the hierarchy, okay? Now complete document is there. Now you want to form the cluster. Already you have formed 2 clusters, but the thing here is this is overloaded. Then what we can do? You can create one more subcluster which will be having the relationship called hierarchy. Okay, so this is the example. And next one, automatic generation of this one will be present on the vocabulary. So whatever the vocabulary we are including in thesaurus, that can be incorporated, and all the selection of this step, selection of this item should be step-by-step process, not we have to directly decide and use it. So the process starts with the collection of the tokens, whatever the words we are using. Then you have to identify other steps according to the algorithms what you are going to use. And after that you have to automate the method for the clustering documents using various algorithms. And what are the different set of words and phrases you are going to add. And inclusion of an item in a cluster is based upon the similarity of the items related to that particular cluster. Okay. So what we will do is, how I start. Suppose I have a cluster document called hello world. So first I have to token, I have to check which cluster it belongs, Suppose if I take C1, C2, over. Now again I got hi Hyderabad. So here hello and hi belongs to same cluster, right? So hi will have the C2. Coming to Hyderabad, it is a place. Again, I can club with the world. So whenever I am clustering, what is the similarity between these two? So if I am taking the similarity here, already one word is called hello cluster is there. Hi belongs to this, right? So similarity is more. Then only you can include this word into this cluster. So that is the meaning of this slide. So in the complete term relation method, the similarity between, you can also calculate term pair. What is the term pair here? Hello, hi. So this is, generally it is not a term pair. If I take hello, welcome. So this is a term pair. Okay. So what is the term pair? What is the probability of getting this particular terms as a single word in the case of the clustering part? Then you can combine into only one cluster called C1 instead of splitting the word and hello as a separate cluster, welcome as separate cluster. Okay. So this is called term pair, which is calculated determining on the cluster. And all these clusters we have to define within the vector models, where you will create the complete vector. All the clusters will be there. And if any hierarchy is there, so this cluster will be formed in the another vector model, and this will be easily represented using the matrix. So you have to create one matrix. So what is your cluster name, what is your term, and which document it is going to mention. So this can be done with the help of matrices and vectors. So the values in the matrix will represent your strong relationship, okay, between the two values, how strong they are. For example, okay, one second. Yeah, if you see here, I want to show this. Yeah, done. So you have the term 1, you have the item 1. What is the similarity between these two? It is only 0. So these two are unrelated. Okay, these two are unrelated. Again, item 1, term 2, it is 4. If I take my range is 5. Okay, my final maximum range is 5. So this is okay. 0, this is not okay. Not okay, not okay. So this is okay. If I take 1, 2, 3, 4 up to 5, it is okay. So like this you have to build the matrix for term relations for each term and one item. So this is the formula for your finding the relation. So you have term I, term j. What is the summation of the product is your relation. So this is an example what we have done. Now this is a description. What are the elements where k is summed across the set of all items. So if you have two columns, means the meaning of it is two terms being analyzed, multiplied and accumulated the values, and the result can be placed called as term matrix, where according to this Salton, M is the number of columns in the original matrix. Okay, it is represented as M by M matrix. So how many terms you are checking with how many items. So this will be M cross M. So this will be term and this will be term. All the terms T1, T2, T3, T1, T2, T3, so on like that. So this will be generated using the previous formula, and you can also use a reflexive property and you can create the symmetric matrix. So this is the thing for calculating the similarity. So using the above data from the given figure, there are no values in the diagonal because you are not autocorrelation of the word. Like the meaning of this is, when I am drawing the matrix, you don't get the diagonal values, means 1, 1. So this is not there. 2, 2. This is not there. Means I am not comparing with the same elements. So this is autocorrelation of the word. Okay. And next step you have to consider that which belongs to the same class or not. I cannot C1 is there, C2 is there. I cannot find the similarity between C1 term and C2 term. I have to only find the similarity, the terms which are present in the same cluster, right? So this will be not there. And always the threshold value, you can use it 10. So you can use 5 or 10. That depends upon your application. Okay, in the previous example, we have used only 10. So this produces a binary cell matrix called relationship matrix, as we have seen. And what are the similar matrices, similarity between these two? Term 7 demonstrate that term may exist its own, no similar terms are identified. If you have the matrix, okay, here TT is there if it is 0, or if for this particular term I am getting all zeros, means what is the meaning? There is no similar value related to this term. Okay, in any of the clustering process, always we can migrate to a class by itself. Yes, this is important point. What we have to do is, if I am taking two terms, right? If I am taking two terms, the similarity between these two terms is 0, means I can shift this term to another class. So this we can do it. So this can migrate to a class by itself, or we can manually do it. So the final step is determine when two objects are in same cluster or not. Yeah, this is very good. So after getting your complete matrix, I'll draw one matrix for class 1 or cluster 1, cluster 2. If these two are similar, what I can do? I can club into complete C1. Got it? So same cluster. Suppose if I create C1, C2. So there is no match between these two. So I can, individual clusters will be continued. So in order to do this similarity, we can use click, single link, star and common components algorithms for your clustering. So this is the thing. So we have done term matrix and term relation matrix. So term matrix, what is the term 1 to term 7? So you have to check all the frequencies. Here what is a relation. Then what we are going to do? Finally, you have to create the classes. So if you see here, after checking then using this particular table. So finally, just we remember what is the algorithm we are doing. First, you have to select the term in the class, place it in a class with all other terms and relate it. For each item, suppose you have C1, C2. I'll start with T1, T2. First, I should find the relation between T1. First, I'll then find with T1 with T4. After T1 is done, with all the clusters in the second cluster, then you have to go for the next one. After that, when new terms can be identified, or till the new all the terms are related, then you have to form the class. Thank you.